By the end of this video, you'll understand the architecture behind every app you use, the same diagram cloud engineers get paid to draw. No jargon, no fluff, just AWS explained with pictures. Let's go. Before the cloud, putting an app online meant buying real physical servers weeks in advance. You had to guess how popular you'd be and pay for everything up front. Guess too low and your site crashes when people show up. Guess too high and you've burned money on machines sitting idle. There had to be a better way. So what changed? Instead of owning servers, the cloud lets you rent them. It works just like electricity. You don't build a power plant in your basement. You just plug into the grid and pay for what you use. With AWS, you can spin up one server, or 1,000, in seconds, and when you're done, you switch them off and the bill stops. It's the same on-demand model that lets a tiny startup launch from a laptop, and lets giants like Netflix stream to millions, all on the exact same cloud. Here's the whole cloud on one shelf. Every AWS service, and there are hundreds, is really just one of 6 jobs. Run your code, store your data, connect things on a network, remember data in a database, watch what's happening, and pay for it. Keep this shelf in your head, and every new service just drops onto a shelf you already know. To make this real, we'll build one app together. It's called PhotoApp, a photo sharing app, and our goal is to put it online for 1,000 users. Along the way, we'll give it everything from those 6 shelves, the compute to run it, storage for the photos, a database, a network, and security. By the end, you won't just know the services, you'll have built the whole thing. Quick recap. The cloud just means you rent computing instead of buying it. You run your code on rented computers, store your files in the cloud, and scale up or down on demand. For PhotoApp, that means renting a server and storage, no hardware to buy, and you pay only for what your users actually use. AWS divides the world into regions, and a region is basically a place you choose. North Virginia is a region, so are Ohio, Oregon, and Northern California. You pick the one closest to your users, so for a US audience, you'd host PhotoApp in North Virginia, so it lives nearby and feels fast. Inside, each region sit availability zones. Think separate buildings. North Virginia has several, named us East 1A, 1B, and 1C. They're miles apart with their own power, so if one Virginia building loses power, the others keep running. That's the secret to high availability. You simply spread PhotoApp across 2 of them. Then there are edge locations, hundreds of small sites much closer to people, in cities like New York, Chicago, and Los Angeles. They don't run your app, they keep cached copies of your content. So a user in LA is served from LA, not all the way from Virginia, which makes it feel instant. Now the scary part, the bill. The good news, you pay only for what you use by the second. But the free tier isn't unlimited, it's 12 months, with limits, and a few things quietly bill even when idle, like a NAT gateway or an unused address. So do one thing today, set a $1 budget alert, and AWS will warn you before anything gets out of hand. Security on AWS is split, like a rented apartment. AWS secures the building, the hardware, and the data centers. You secure what's inside, your data, and who you give the keys to. And to be clear, other customers can't see your data, and neither can AWS. Almost every breach you read about is a tenant who left their own door unlocked. IAM is the identity system. It decides who can do what. A user is a person, a role is a temporary pass, a service or person puts on for a job, and a policy is the written list of what's allowed. The golden rules: services should wear roles instead of carrying passwords, never run day-to-day on the root account, and always turn on multi-factor authentication. Quit basics, because everything builds on this. A server is just a computer that's always on, waiting. A client, like your phone, sends it a request, and the server sends back a response. That little round trip is the whole game. Every service we meet is just a smarter version of this. And 3 quick words that unlock the hard part coming up. An IP address is a server's phone number. A port is a numbered door on it, 80 for the web, 443 for the secure web. And DNS is the internet's phone book. It turns a name, like photoapp.com, into that phone number. Learn these 3, and the networking section suddenly makes sense. Finally, how do you actually use AWS? 4 ways. The console is the web dashboard, great for learning. The CLI is the command line. The SDK lets your own code talk to AWS. And infrastructure as code lets you build your whole setup from a single file. Same AWS underneath will start in the console and graduate to code. Let's pull the foundations together. A region is a city, like N Virginia. Inside it, availability zones are separate buildings, 1A, 1B, 1C. Edge locations cache content close to users, in cities like LA and Chicago. Pricing is pay per use with a free tier. Shared responsibility means AWS secures the cloud and you lock your own door with IAM. And you reach all of it through the console, the CLI or code. PhotoApp lives in N Virginia across 2 zones, so one building failing never takes it down. PhotoApp's code has to run somewhere, that's the compute shelf. You've got three main choices: EC2, a full virtual computer you control; Lambda, code that runs only when something triggers it; and containers, your app packed into a box that runs anywhere. Let's meet each one. EC2 is the most literal piece of the cloud, a virtual computer you rent by the second. You pick its size and operating system, and it's yours. The catch, because it feels like your own laptop, you inherit the babysitting, patching, scaling, replacing it if it dies. A handy trick, even a single EC2 placed inside an auto-scaling group heals itself when it fails. And here's the #1 interview question: how do you pay for EC2? On-demand is flexible, but priciest. Reserved or a savings plan commits you for 1 to 3 years and saves a lot. And Spot uses spare capacity for up to 90% off. The catch is AWS can take it back. Match the model to the workload, and you cut the bill dramatically. A few pieces live around EC2. An AMI is a golden image, a saved snapshot of a server's operating system and setup, so you can stamp out identical copies. EBS is the hard disk bolted to one server. A snapshot is a point-in-time backup of that disk, saved safely in S3. And an elastic IP is a fixed public address, because the free one changes every time you stop and start. Lambda is code without a computer to manage. You upload a function, and it runs only when an event fires, a file lands, a request arrives, and you pay per millisecond, nothing while it sits idle. Serverless doesn't mean no servers, it means AWS hides and runs them for you. It's perfect for short, spiky, event-driven jobs, just remember the 15-minute limit. So which do you pick? It's really about how much you want to manage. Choose EC2 when you need full control, or have steady, special workloads. Choose containers on ECS or Fargate for portable apps with variable load. And choose Lambda for short, event-driven, spiky work. More control on the left, less to manage on the right. PhotoApp's photos need a home, the storage shelf. S3 is an endless warehouse for files. EBS is a disk for one server. And EFS is a shared drive many servers can mount at once. The trick is picking the right one for how you need to reach the data. Now, the biggest myth in AWS S3 is not a folder tree. It's a flat code check. You hand over a whole object and get back a key, a ticket. Those slashes you see in a name are fake. There are no real folders. You can't mount it like a drive or edit a file in place. You get and put whole objects. It's the default home for almost any file, with 11 nines of durability. And you don't pay the same for everything in S3. Standard is for hot data you use a lot. Infrequent access is cheaper for things you touch now and then. And Glacier is a deep freezer, dirt cheap for old archives you rarely open. Best of all, lifecycle rules move old data down to the cheaper tiers automatically. Quick recap of storage, by how you reach it. EBS is a disk bolted to one server, block storage. EFS is a shared drive many servers mount at once, file storage. And S3 is the warehouse you reach over the web, object storage, same data, 3 very different doors. And the compute and storage recap. EC2 is a full virtual computer, Lambda runs code on a trigger, and containers pack your app to run anywhere. For storage, S3 is an endless warehouse, EBS is a disk for one server, EFS is a shared drive, and Glacier is a deep freezer for old archives. For PhotoApp, thumbnails resithe on Lambda, originals sit in S3, and old albums slide down to Glacier to cut the bill. Beyond files, your app needs a smart place for structured data. That's a database. AWS gives you 2 managed kinds, RDS, the SQL type, and DynamoDB, the NoSQL type. Managed means AWS handles the backups, patching, and failover for you. PhotoApp keeps its users, captions, and likes in one. RDS is the database most people already know. It runs familiar engines like PostgreSQL and MySQL, storing data in neat tables of rows and columns, with powerful queries and joins. AWS runs it for you, backups, patching, even a standby copy that takes over if the main one fails. Reach for RDS when your data is related and you need it consistent. DynamoDB is a different beast, a NoSQL key value store built for massive scale. Instead of tables and joins, you look things up by a key and it answers in single-digit milliseconds, no matter how big it gets. It's serverless, so there's nothing to size, you just pay for what you use. Perfect for huge, simple lookup workloads. So which do you pick? If your data is related and you need complex queries, choose RDS. If you need enormous scale with simple lookups, choose DynamoDB. A good rule, start with RDS unless you know you need Dynamo. For PhotoApp, user accounts and their relationships fit RDS, while a high-speed activity feed fits DynamoDB. Now, where do all these servers actually live? Inside a VPC, a virtual private cloud. Think of it as your own private walled-off slice of AWS. Nothing gets in or out unless you allow it. You pick the address range and the doors, and PhotoApp servers sit safely inside. You split that VPC into subnets, rooms in your building. A public subnet faces the internet for things like web servers. A private subnet stays hidden for sensitive things like your database. Rule of thumb, keep databases private, never public, and spread your subnets across 2 availability zones so a single failure can't take you down. Around every server sits a security group, a personal firewall. It only allows the ports and sources you list, like HTTPS on port 443. Everything else is blocked by default. One key thing, a security group filters by IP address and port, not by who you are. Identity is IAM's job. But what about a private server that still needs updates from the internet? That's where a NAT gateway comes in. It lets your private servers reach OT to download patches, while blocking anything trying to come IN. A one-way door, safe outbound access with no inbound surprises. Now let's lock things down. Never ever hard-code a database password in your code. That's a breach waiting to happen. Instead, store it in Secrets Manager, a locked vault. Your app's IAM role fetches the secret at runtime, and you can rotate it anytime without touching a single line of code. What happens when your app suddenly goes viral? Autoscaling has you covered. When traffic spikes, AWS automatically adds more servers. When it's quiet, it removes the extras. You never overpay, and you never crash under load. Pair it with a load balancer to spread traffic evenly across them. And to keep an eye on everything, there's CloudWatch. It collects metrics, logs, and dashboards for every service. You set alarms, say, if CPU goes over 80%, tell me, and that alarm can trigger autoscaling or send a notification. Remember, you can't fix what you can't see. Tie it all together with one golden rule, least privilege. Give every user and every service only the access it actually needs, nothing more. Turn on MFA and never daily drive the root account. AWS secures the cloud itself, you secure your part. And most breaches aren't clever hacks, they're just a door someone left open. Take a breath, look how far you've come. The cloud is renting instead of owning. Compute, like EC2 and Lambda, runs your code. S3 stores your files, and databases hold your data. Regions and availability zones keep it running safely, IAM controls who can do what, and you pay only for what you use while the edge serves users fast. That's the core of AWS in one picture. Now it's your turn. Here's your first project, take PhotoApp and put it in the cloud. Run it on an EC2 server or Lambda. Keep the photos in S3 and the app data in RDS. Lock it down with IAM and set a $1 budget alert on day 1. Do that and you've just designed a real cloud system. And that's AWS, made simple. No jargon, just pictures. If this finally made the cloud click, subscribe to Viaan Cloud. Next up, networking security and scaling. Tell me what you want explained in the comments. See you in the next one.